Hello, everybody. Welcome back to our discussion dynamics. Today we'll start a new topic. We'll start work energy of particles, as you can see on the board. Yeah. And that's why, if you look at the course content, we are here. Yeah, we are just at step number 3. So we can get rid of these two things from our course content, yes, because we already done them. However, they will come back a couple of times. Okay, it doesn't mean that you can forget about them, yeah, because they might appear either in this topic or in this topic. Okay, maybe even in these topics. Yeah, we'll see what Professor Sunny prepared for us this semester. Okay, plan for today is brief lecture overview or brief lecture review and example number 1 and example number 2. Let's start. So what can I say about work energy methods for particles? So I would like you to recall our good old friend particle P that is following this trajectory. Okay, particle P is following this trajectory, and please imagine that some force F, okay? Some force F, net force, is acting on our particle. F, this is a net force. Okay, so we can write our expression F equals to ma, yeah? Because our particle has mass m, force F acts on our particle. That means that our particle follows the trajectory. So that means that there will be a resultant acceleration, yes? And by the way, guys, because we never talk about it probably, we just started using this expression, yes? Yeah, all of it, like, I don't know, like 2 weeks ago, we just started using F equals to ma, yeah? Can you please tell me why F equals to ma? Why this is true? Why F equals to ma is true? Anybody? Hamilton? Newton's second law is exactly this. This is Newton's second law. Newton's second law says this is true. This is what in Newton's second law. But why? Okay, no worries, no worries. Yeah. John? Okay, you are closer, and I think you are even right, maybe. Yeah. Anybody else? Just can you explain it? I try to explain everything in simple words. Can you explain this in simple words? Why this is true?
I guess I don't know if that in a more simple term than Newton per meter per second.
So you just express this equation in different form, in unit form. Yes. Okay. So it's you are not answering my question. Do you see that? You just reread what's written here. Scott.
Yeah. Force on something.
Why? Exactly, but why? Do you see? This is exactly my question.
Yeah.
Why, if I apply force, it will accelerate in this fashion? Yes. Yeah. So I will tell you why, guys. Okay. Or do you want it to be your homework? Do you want to Google it? Just Google it. Why? You have Google. You have solution manuals. Use solution manuals, maybe. Yeah. Okay, I'm gonna tell you. I don't know the answer. I have no idea why F equals to ma, and you were right, John. Yeah, so you were right because John said that Newton proposed that because he observed that experimentally. Yeah, we know that because experiments tell us. This is how our world works. Why? I don't know. It is just this is so-called axiom. This is axiom. Yeah, I think this is correct English word. Yeah, axiom. Second axiom of dynamics. Yeah? This is second Newton law. Yeah, there are two more Newton laws, first and third. Yes, and you all know them. Yes, you're engineers, guys. Okay, make sure that you know them. Okay, it's scary sometimes that you don't know them. Yeah, and I know that some of you don't know those rules. Yeah, but it's scary. So yeah, I don't know. This is how our world works, and if you wanna answer that question, you probably need to go into maybe some theology even. Yeah, because I don't know why this is true. Yeah. So F equals to ma, and we agree with that. And just what we gonna do to go to, and you were very close, John. Yeah, or maybe you were even right. Yeah, just I wanted like very simple explanation. Yeah. So what we are gonna do, we're just going to project this expression on our path. Okay. This is projection on trajectory. Yes. On trajectory. Yeah, this is our ds. Yeah, that little thing is ds. Okay, okay. So ds is equal to dsut. Yeah, and just remember, guys, that a we can express as atut plus an. Okay. So what will happen here? Maybe wait a second. So I will have f times ds, and this is equal to ma times ds. Yep. So we'll have f times ds. And can you guys tell me what is this equal to? What is this equal to? Based on these two definitions? If I multiply a times ds, we will end up with anybody? Okay, I'm not going to like, if you don't want to take participation, don't worry. I'm not going to like tell you like, Maya, you say. No, I'm not going to do it. Okay, yeah, that will be ATDS, yeah? ATDS, yeah, you all know that. I hope at least. And just remember our definition for ATS, or basically AT is either dv dt, yeah, or our AT is equal to v dv ds, yep. So we're gonna, of course, go for this one, yeah. If I plug this expression in this formula, we will end up with f times ds for the third time, m v dv, right? And we're going to integrate. We're going to integrate from point A on the path to point B on the path, or on trajectory, okay? Let's say that point A is here, and point B is here. So we will just integrate our f equals to ma along this trajectory, just this curve, okay? And just by the way, this is definition of work. This is work. This is work. Work of force F. Okay? And this integral will be 1/2 mv squared from point A to point B. So this will be 1/2 mVb squared minus 1/2 mVa squared. Looks like definition of kinetic energy for me. Yes? So this will be exactly TB minus TA. Or I actually, instead of B and A, I use number 2 and number 1. So instead of B, I'm going to put 2 in here. Instead of A, I'm going to put 1 in here. So yeah, we ended up with work energy equation, yes? So this is work of force F. Just let's put it in more mathematical form. So that will be U12 of F, of all forces, okay? So we can end up with U12 of all forces is equal to T2 minus T1. So I prefer this form. T1 plus U12 is equal to T2. Yes, this is the equation we are going to use twice today. Yeah, so this is how we get from F equals to ma. That is for some reason true, and it is true. Oh, sorry, it is true, of course, when velocity is much smaller than speed of light, yes? When velocity is much smaller than speed of light, yes? When we get closer to speed of light, relativistic effects happen, yes? And F equals to ma is no longer true, yes? But I operate way, way, way below speed of light, okay? So that, yeah, I just want to clarify that. Yeah, so basically kinetic energy at the beginning. We start with some kinetic energy. There is some work of forces acting on our particle, and we will end up with different kinetic energy. This is that equation, yes? Any questions? Okay, if there are no questions, let's start example number 1. And as usual, please familiarize yourself with the problem statement before we start our solution. However, no, I have one more thing to say. Wait a second. Sorry, guys. Let's also focus on this term. Sorry. We are going to continue lecture review. Okay, so let's focus on this term very quickly. Okay. So I'm not sure. So let's imagine that, like in here, our F points in this way, yeah, and our ds points in this way, and there's like some angle gamma between them, yeah. So what does that mean? If we have force F acting this way, and ds acting this way, and there's gamma between them, so by definition, F times ds is equal to F ds cosine gamma. Yes. So let us consider 3 cases. Okay. Gamma equals to 0 degrees. Gamma equals to 90 degrees. And gamma equals to 180 degrees. So what does that mean? That means that our F points this way, and our ds points this way as well, yeah? That means that our ds points this way, and our F points this way. Yep, and the final case is about ds pointing this way, and F pointing this way. So in that case, cosine of 0 is how much? How much? 1, exactly. So that means that our F times ds is equal to F ds. Yep. And cosine of 90? 0, exactly. So that means that our F times ds, work of such force would be 0. Yep. And this guy, cosine of 180? Yeah, so that means that this force will be negative. Yeah, this will be dissipation of energy. Yes, this work will take away energy from our system. Okay, do you know, can you guys tell me, for example, can you tell me example of such case? Which force will dissipate energy then? Exactly, friction is, for example, is example of such force that dissipate energy. And you can come up with examples of these two at home. And now, as promised, please familiarize yourself with the problem statement before we start our solution. All right, so what do we have in here? We have our car. We're gonna model it as particle. We have gravity acting downwards. We know that mu k between tires and the ground is 0.7. We know that incline is 20 degrees, and we know initial velocity that is 12.5 meters per second. They ask us to find distance, this distance, yeah, where car stops. Okay, this is 0 and this is unknown. Okay, solution. Oh, and by the way, they told us to neglect all forces besides gravity and friction. We are not going to listen to them, okay? We're gonna include all the forces, okay? We're gonna include all the forces and the solution should be exactly the same, okay? So this is our, so we're gonna start solution with this expression, T1 plus U12 is equal to T2, okay? Because this is another form of F equals to ma. It's an integral of F equals to ma, and we will just find what is T1, we will find what is T2, and we will find what is U12, okay? This is my approach to these problems. And if that, yeah. So how about starting from the easy one? What is kinetic energy at the end? Exactly. 0. At the beginning, 1/2 m v0 squared. Yep. And now we should find this guy, okay? U12. So, but before that, let's draw FBD, okay? Let's draw a free body diagram. And let's model our particle as this rectangle. So what forces act on our structure? We have gravity, they told us to include it, yeah? We have normal force. And we also have friction, yeah? There are no other forces acting on our system. And I think that this is our trajectory, right? This is our trajectory. This is trajectory of our point, so that means that ds points this way, yeah? Do you agree with me, guys? Yeah. So let's do, and this is theta, of course. So that will be mg cosine theta, and that will be mg sine theta. Yeah, because theta will be here. Okay, so now we see all the forces acting on our system. So I think that our work of forces, our work of the net force is following. Work of gravity plus work of friction and work of normal force, yes? Work of normal force. Yeah. Yeah, work is an additive quantity. That's why we can express our work as a sum of works of separate forces. Okay? But this is not mathematical formalism, yes? Let's put it in more mathematical formalism, okay? So I would write that this is U12 of mg plus U12 of tf as a vector plus U12 of n. Okay? And now let's put it even in more mathematical formalism. So U12, let's put it here. U12 will be integral from point A to point B. We will replace that A and B later, okay? We'll replace it with some numbers of mg times ds plus integral from A to B, so from start to the end, of tf times ds plus integral of AB, sorry, from A to B of n times ds. Okay, so let's start from the end. What can you tell me about work of normal force? How much is this integral? Why? Tom, you said it, yes? You said 0. Oh, and your name has to be Caleb. Isaac, okay. Sometimes I'm wrong, yeah. One more time? Yeah, so the first part of your answer is not good, you see, because you said it's not acting in the same direction. But this force, for example, is also not acting in the same direction. But work of the red force will not be 0. It is perpendicular, exactly. So this is 0 right away. This is 0 because n is perpendicular to ds. Thank you, Isaac. Okay, so that's why, I don't know why they told us to include only mg and tf. We could also include n because it's 0. Yes. Anyway, that's why we didn't listen to them. Okay. So how about this thing? U12 is equal to. So what is the resultant of this? If you look at this picture, what we will obtain if we project mg onto ds? Yes, mg sine theta ds. Yep. How about friction? And by the way, we are in kinetic friction. Yes, we are in kinetic friction. So we will end up with Tf equal to mu k mg. So what is resultant of this dot product? I know you know mg ds. Okay, but you can tell me the integration bounds. What should I put here and here? Perfect. 0 to d and 0 to d. And all of our integrands are constant. I hope you can see that. This is constant. And this is also constant. Yeah, just a second. So we will end up here with mg sine theta d plus mu k mg d. Okay, so this is our work. This is exactly our work. Okay, so we found, you guys helped me finding this, this, and this. Yeah, 100% of the problem done. Yes, I see there are 4 questions. Okay, so we found T1, T2, and U12. Okay, what's the question? And I think you. Oh, shoot, you're right. Thank you. Of of course, because this is there is like 180 degrees between them. Yes, thanks. So minus will be here as well. Yeah. Okay, and Anna, you had the same question, and Isaac, you had the same question, and you, Jason.
Why is it MD and not MD cosine theta?
Because, my friend, mg cosine theta acts along this direction. Yes, and ds acts along this direction. Yes. So if you project black vector, yes, this black vector, if you project on ds, you will end up with this quantity times ds, because this quantity is aligned with ds.
No, for UK and
Oh shoot! Yes. Yeah, but yeah, mg cosine theta. Yes, sorry, mg cosine theta. Yeah, I just heard that. Why is it not mg sine, not cosine? Sorry, I was my bad. Yeah, thank you for paying attention. Cosine theta d. Thanks. Okay, so what shall we do next? We found these three guys. Let's plug them back in. Let's plug them back in into this formula. Okay. So we will have 1/2 mv0 squared plus mg sine theta d minus mu k mg cosine theta d equals to 0. Okay, find d. By the way, that m cancels out in my opinion. Yes, that m cancels out. And d is equal to v0 squared 2g mu k cosine minus sine. Plug in values and obtain that our d is approximately 25.221 meters. This is the answer. Okay. Questions? These are the solution steps so far. Yeah. So solution step so far is writing this expression, then finding these three guys correctly, of course, and then plugging them back in, and the rest is algebra. Okay? Easy problem? Do you have any questions, guys? Another example? Let's do it. Please familiarize yourself with the problem statement before we start our solution. All right. So in here we have the solution steps will be exactly the same. Okay, exactly the same. Just the only difference is maybe that we are going to use US units this time, US units. Plus there is a cubic spring. Cubic spring. Maybe some of you will see it for the first time in your life. Usually you guys are probably used to linear springs, yes, that are governed with this expression. Yeah, linear spring. Now we're gonna talk about cubic. Okay, solution. Are you surprised if I'm gonna put this expression on the board? And second step is obviously finding these three guys, T1, T2, U12. Okay, so at the end, they told us that at the end our particle should stop, yes? So you guys already told me that at the end our T2 will be 0, yes? Because no particle stops, both stops. And we start with V0, yes? This is what they ask us to find. What is the maximum V0? So at the beginning we'll have 1/2 mv0 squared. And now U12. So okay, so now we have how many percent of the problem done? 67, yes? 66% of the problem done. So now U12, we must draw FBD before we find U12. Maybe here. So what forces act on our boat? They told us to neglect the drag. Okay, drag force between the water and the boat. Okay, so we're not going to include that. And they also told us to get rid of mg, yeah, mg and n. Yeah, they told us to neglect that. However, even if we include them, the solution will be the same. You see that, yes? Because they are perpendicular to the motion. Okay, so there's only one force acting on our particle, yes? It's beta x cubed. Yeah, and this is our trajectory. This is our trajectory. So you guys can see that our ds is pointing this way. Yeah. All right, so you have only one force acting on that system. It's work of spring. So it's work of spring. So let's put it in a mathematical form. So this will be U12 of, oh, they call it FB. FB. Here you can see that they call that force FB. And let's put it in even more mathematical force. This is integral from beginning to end of FB times ds by definition. Okay, so this seems to me to be integral of beta kx dx with a negative sign, yeah? And the integration bounds will be from 0 deflection to deflection max, delta max. Or x max, yes? Oh, sorry guys, look, I defined it as x max. So not, I don't know if you like that joke, but I'm gonna say it. So not everybody's favorite letter this semester, but just x. Okay, x max. All right, so we're almost there, just we have to integrate. If I remember correctly from school, that integral is equal to negative a quarter beta x to the power of 4 from 0 to x max. So that would be negative 1/4 beta x max to the power of 4. Okay, so it seems to me that 100% of the problem is done because we found this, we found that, and we found that. Okay, what's the third step of our solution? Take these three guys, plug them back into our original equation. And we're gonna do it. So we will end up with 1/2 mv0 squared minus 1/4 beta x max to the power of 4 equals to 0. They ask us to find v0 max, yeah? So v0 is equal to square root of something, 1/2 beta x max to the power of 4 divided by m. Okay, let's plug in values. Since these are US units, I'm going to plug in values because some of you are still having problems with that. So it will be 1/2 divided by 3.5 times 10 to the power of 6 times 0.5 to the power of 4. And in here, instead of, we will do 70,000 divided by 32.2, okay? Some of you are still forgetting to divide by 32.2. But only some of you, not everybody, I know. If you grab your calculators, you will end up with V0 equal to 0.7093 feet per second. And this is the end of the problem. Questions? Okay, it seems like we are, yeah, we still have 12 minutes. Yeah, and we are done with the discussion. Okay, any questions? Yeah. So thank you for today and see you on Friday.